All right, now let's talk about solving by graphing. So same thing, we like this whole section, you're going to see that basically what we're given is the same, right? We're given two equations, two linear equations, and we're going to solve them. So the difference is how we do it, right? So so basically when we're graphing, the first thing we want to do is we want to solve for y. Okay, same thing as before. We want to get it to slope intercept form. This time, because that's just an easy way to graph, right? Because we have the y-intercept that we can plot, and then we can use the slope to find the next point. So I'm going to do that with these two equations. So first, I'll do that. I'll subtract 2x from both sides to get the first y isolated. So we'll end up with negative y equals negative 2x plus 6. Then I want to get rid of this negative in front, right? And so it's an invisible 1 there. So I'm going to divide everything by negative 1. You could also multiply by negative 1. That's fine too. So then I'll get y equals negative 2x divided by negative 1 is positive 2x. 6 divided by negative 1 is negative 6. So we'll call that our y1. So our y2, bring down here, I'm going to start by subtracting x on both sides. So I'll get 2y equals negative x minus 2, right? Remember, these aren't like terms, so I cannot combine them together. So I'm going to divide everything by 2. And so we'll get y equals negative 1x over 2, or negative 1/2 x. And then negative 2 over 2 is negative 1, right? So that's y2. So let's plot these. So the first one, y-intercept of negative 6. So I'm going to go 1, 2, 3, 4, 5, 6. And slope of 2. So it's going to go up 2 over 1, right? So it'll be this line right here. All right, so that's y1 in blue. And then in purple, y2, we have a y-intercept of negative 1 right here, and a slope of negative 1/2. So it goes down 1 over 2. All right, and I think we just found our solution there. So now I'm going to graph those lines, or this line, excuse me. Okay, so there's y2. All right, now I kind of missed the point here, but I'll make the point a little bigger. But that's where they intersect, right? That's the solution. When you're looking at a graphical solution, you want to find where do the lines intersect, and they intersect in this case at negative, or excuse me, positive 2, negative 2, right? So it'll be positive 2 when x is positive 2 and y is negative 2. That's where these lines intersect. Okay. All right, so that's how you do it graphically, is you solve for y, get it to slope intercept form, you graph the lines, and then you see where they cross, right? Now, downside to doing this by hand is, you do have some inaccuracy, some human error, right? Like you saw with mine, where, my line kind of curved a little bit there and wasn't exactly that point. So, but it's pretty obvious that that's where it was. You can also plug these values in and check. So you can plug them into both this one and see if they come out the same. See if your y values come out the same. So plug in 2 for x and see if y comes out as negative 2 for both. So the other thing we can do is use our graphing calculator. All right. So what we can do is, same thing, we do have to solve for y whenever you use your graphing calculator, because that's how we input them, right? So it's the same work on the front end, but then we can use our calculator, plug them in, and calculate the intersection. Okay, so let's try that for number 4. So I'll start with the first equation. So I want to subtract 5x from both sides. So I'm going to get negative y equals negative 5x plus 4, right? So then I'm going to divide everything by negative 1 to get rid of the negative. So we end up with positive y equals positive 5x minus 4, right? And we'll call that y1. So for y2, I'm going to start by adding 2x to both sides. And so we'll end up with 6y equals 2x plus 4. So we need to divide everything by 6. So we get y equals 1/3 x 2 over 6 reduces to 1/3, and then 4 over 6 reduces to 2/3. All right, so we'll call that y2. So now we're going to input these in our calculator. So you're going to go to the y equals menu and put those in. All right, so yeah, once again, y equals, go to your y equals menu, and then plug in, input these functions, y1 and y2. Okay, then what you're going to do is you're going to, if you haven't already, zoom 6, that gets you to a standard window, and that'll actually go straight to the graph. But you can also push graph. Okay, so zoom 6, or you can push graph, and then if you need to, zoom 6 to get back to a standard window. So you'll get something that looks like this, and so you can actually see where the intersection is, right? That's what we want to find. So you can kind of try to trace it out and say, well, it looks like maybe 1, 1, you know, a little hard to tell, maybe a little after 1. So so you can zoom in and things like that, but there's a way to actually calculate the answer exactly and efficiently too. So the calculator does that for you. So what you're going to do is you're going to go second and then trace, and that gets you on the calculate menu. Okay, so second, trace. So here's what the calculate menu looks like, right? Is you'll get these options here. Now, which one do you think we want to use? That's right, intersect. Okay, so we're going to go, so second trace gets us here, right? And then we want to push 5. So second trace 5. So then you get a series of questions. Okay, it's gonna say first curve, like this, right? And basically you just want to be on, you know, one of the curves. Usually it'll default to y1. So then just push enter. So it'll say first curve, you just push enter. Okay, so this is after you do second trace 5. It'll say first curve, you push enter. Then it will go to second curve. You just push enter, right? Make sure, you know, maybe double check that it's on y2, but just push enter. And then it will say guess question mark, and you just push enter. Okay, now this would be a bigger deal if you had more than 2 curves that you put in your y equals menu. Then that's why the calculator is asking, because you can put up to 10 functions. So the calculator just wants to know which 2 you want to find the intersection of. And then for this last one, with linear functions, remember that usually we're going to have one intersection. The only way we can have more than one is if they're the same line, like we talked about, if they're consistent and dependent. And so, but most of the time we have one intersection. So the guess, excuse me, doesn't really matter too much, because it'll just find the only one that there is. If you had a situation where you had a curve like a parabola, you might have 2 solutions, and that's why the calculator needs you to guess, so that the calculator knows which one to find, which one that it needs to calculate. Okay. All right. So anyway, that's why they have that. So basically, you're just going to go second trace 5, and then enter, enter, enter. Okay, is basically the process. All right. So once you do that, then it's going to give you the intersection. Okay. So it'll say x1, y1. Or excuse me, x equals blank and y equals blank. So in this case, it was 1, 1. So that's our solution. All right. So that's how we solve by graphing, either by doing it by hand on paper. I would recommend using graph paper for that. So, because like I said, there's already some human error involved. So the more precise you can get it, the better. And then and you might want to check after you finish that. The other way to do it is by using the calculator. And so you do, you plug in, set them equal to y, set both equations equal to y, slope-intercept form, and then plug them into your calculator under the y equals menu, y1 and y2, and then you basically do second trace 5, enter, enter, enter.